All right, so now we're going to solve this rational equation. Again, you factor the denominators, and then you put parentheses around anything with two terms. So then what multiplies to be a times c adds up to be b. What multiplies to be negative 3 adds up to be 2. 1 times 3, negative 1. Negative 1 plus 3. So this factors to be x minus 1 and x plus 3. So I'm just going to cross that out so my brain doesn't try to overcomplicate this. So now from here it looks like the least common denominator, this one's going to need an x plus 3 to the bottom, an x plus 3 to the top. This one needs an x minus 1 to the bottom and an x minus 1 to the top. And then it looks like this one's good to go. So now on top I have x squared plus 3x plus 1x plus 3. Then an equal sign, then negative 1x plus 1. And then we have a plus sign, and then 8. So again, if you wanted to combine like terms, x squared plus 4x plus 3 equals negative 1x plus 9. It is a quadratic equation, and a quadratic we always get set equal to 0. So I'm going to add x, subtract 9. So we have x squared plus 5x minus 6 equals 0. We're then going to factor a times c adds up to be b. What multiplies to be negative 6 adds up to be 5. 1 times 6, 3 times 2. Looks like negative 1 plus 6 is the 1. It quick factors to be x minus 1 and x plus 6. So my solutions now, I find by setting them equal to 0. My factors equal to 0 when solving. So x equals 1 and x equals negative 6. But 1 was also a restriction. Look back at the original. The restrictions are 1 and 3. So I got to cross that one out. It's extraneous. It says use the graph below to find the domain and range. Honestly, I'm not even going to use the graph. Well, I guess I could. Domain's easy though. X cannot be negative 2, right? So our domain will be negative infinity to negative 2, union negative 2 to infinity. And then again, I think this graph's deceiving, so I'm not even going to use it. My range I can find by doing my horizontal asymptote. So if I do the leading term divided by leading term, 3x divided by x is 3. I have a horizontal asymptote at 3. So my range will be negative infinity up to 3, union 3 to infinity. Or, I mean, again, if you were to notice that the asymptote is at negative 2 and at 3, then you could do domain and range that way. It says determine the vertical asymptotes of the function, and then we do that by factoring the bottom, the restrictions. So x plus 5 and x minus 5. The domain restrictions are vertical asymptotes. So x equals 5 is a vertical asymptote and negative 5. Negative 5 and 5 are our vertical asymptotes. Determine the horizontal asymptote. So you're doing leading term divided by leading term. 7x cubed divided by 7x cubed is 1. So our horizontal asymptote is at y equals 1. The x is divided out perfectly, so you divide your leading coefficients, which happen to be 1. It says graph the function. So it was 1 over x. 1 over x was shifted down 2. So it has a vertical asymptote at 0 normally and a horizontal asymptote at 0. If we go down 2, it's now at negative 2. So our vertical asymptote is still at 0. But now our horizontal asymptote is down at negative 2. And we know in the parent function, it's always in quadrant 1 and in quadrant 4. Quadrant 3. So now I just draw a rough sketch here. It didn't get reflected over the x-axis, so I'm still going to draw it in the quadrant 1 area and the quadrant 3 area. If it got reflected over the x or y-axis, we would draw it in quadrant 2 and 4. All right, it says write the equation if it's compressed by 1/5. So that'd be 1/5 times 1 over x, which then simplifies to be 1. We multiply straight across over 5x. So that would be the equation. And it says what happens to the point 1, 1. Stretch and compressions only go to our y value. So what times our y value by 1/5? It says write the equation if it's transformed, right 5, stretch 6, and up 1. So I start with 1 over x, and I just put in what I know. Right 5 will be minus 5 with x. Stretch a 6 will be a 6 in front. And then up 1 shifting up by 1 will be added on the outside. We then know they multiply the fraction straight across, so this will be a 6 over x minus 5 plus 1. Determine the inverse. So we switch x and y and solve for y. X equals 6y plus 1 over 3y minus 3. When we're finding the inverse, we switch x and y. We put parentheses around anything with two terms. We then times this out of the denominator. 3y minus 3. We then distribute x. So 3xy minus 3x equals 6y plus 1. I can drop the parentheses on the 6y plus 1 because nothing happened to them. There was nothing multiplied to it. Then we get all the y's on the same side. So it doesn't matter which way I go. I'll just subtract 6y this way. Anything that doesn't have a y needs to move away from the y's. So I'm going to add 3x over. So now we have 3xy minus 6y equals 3x plus 1. Once we get all the y's to the same side, and then anything that doesn't have a y on the other side, we factor out a y. So left is 3x minus 6. And then to get y alone, we always do one last step, divide the 3x minus 6 over. So we just found the inverse to be 3x plus 1 over 3x minus 6. All right, it says state the restrictions. That's the easiest problem ever because it's already factored. If it's not factored, we got to actually factor it. So my restrictions are -6 and 2 and -7. Unfortunately, this one's not factored. So we have -8x. We got to factor out a -1. Then left is x plus 3. And then we got to factor out a 4. And left is x plus 1. Now, really what we have then is a -8x times a -1 times an x plus 3 times a 4 times an x plus 1. So now you would just state the restrictions. -8 can't be 0. It's not. Move on. X can't be 0. -1 can't be 0. It's not. X plus 3 can't be 0. So -3 would be a restriction. 4 can't be 0. It's not. -1 is our next restriction. So we have 0, -3, -1. So when you factor out a number in front, it is just multiplication. This is still all just multiplication. So that's why I just rewrote it as multiplication. You know what I mean? Because it technically is. So again, to find the restrictions, we have to factor. Oh, what a pain in the butt one. And I don't have my calculator on me. I might have to circle back on the video. That's going to take factoring out a -1. Then left is 16x squared minus 16x minus 5. This one I can factor easily to be x plus 2, x minus 2. Now I just need a long factor. A times c adds up to be b, but again, I don't have my calculator on me. Well, maybe I could use this calculator real quick. Just a second. 16 times 5 is 80. What multiplies to be -80. And a times c adds up to be -16. Okay, 80 divided by 2 is not it, obviously. 2 times 40 isn't 16. 80 divided by, oops. This calculator sucks. 80 divided by 3 is a decimal. 80 divided by 4. 80 divided by 4 is 20. That's it. 4 times 20. -20. I've got to write 16x squared minus 20x plus 4x minus 5. Or maybe I'll reorder it to be plus 4x minus 20x. It just seemed easier to factor. And then we're grouping. The greatest common factor here is 4x. So then left is 4x plus 1. The greatest common factor here is -5. Left is 4x plus 1. So 4x plus 1 factors out. Left is 4x minus 5. What a pain in the butt. So I have a -1 on bottom. Then I have a 4x plus 1 and a 4x minus 1. Then I had an x plus 2 and an x minus 2. So my domain restrictions come from the bottom. -1 can't be 0. It's not. The restriction for 4x plus 1 is -1/4. The restriction for 4x minus 1 is 1/4. The restriction for x plus 2 is -2. The restriction for x minus 2 is +2.